All right, today we're going to pull back the curtain on the unsung hero of our digital world, the database. We're going to go on a little journey, starting with the core blueprint, the big idea, and then see how that turns into the actual digital toolbox that developers use every single day. So let's get right into it. I mean, just stop and think about it for a second. Every single app you use, every website you visit, every online purchase, it's all just data. Mountains of it. Without some kind of system, it'd be total chaos. It'd be like trying to find a specific book in a library where all the books have just been dumped into one giant pile. So how do we find anything? Well, the answer lies in this incredibly simple but powerful idea. And this is it. This is the blueprint that brought order to all that chaos. It's called the relational model. This is the foundational concept, the big idea that lets us neatly structure all that information. And honestly, it's been the bedrock of how we manage data for decades. So here's how we're going to break it all down. First, we'll look at how we organize the chaos. Then we'll get into the power of keys. After that, we'll talk about the language of data, then see how we actually build with SQL, and then how to ask smart questions with it. And finally, we'll wrap up by seeing why, well, our entire world pretty much runs on this. Okay, so let's start at square one. How does this whole model actually take that messy pile of data and make sense of it? Turns out, it really just uses three simple building blocks. So here's the deal. Everything gets organized into tables. You can think of them like spreadsheets. In the fancy database world, they're called relations. Now, each table has columns, like first name, last name, email address. The technical term for those is attributes. And of course, the table has rows, where each row is one complete record, like all the info for one specific person. Those are called tuples. That's really it. Tables, columns, and rows. Simple, right? Okay, so we've got our neat and tidy tables. That's great. But what if a table has, say, millions of rows? How do we find one specific person and be absolutely sure we've got the right one? We need a way to uniquely identify every single row. And that, my friends, is where keys come in. To pinpoint that one specific record, we need a unique identifier, and it's called a primary key. But, choosing the right one is trickier than you'd think. For example, a passport number. That seems totally unique to a person, right? So why would that actually be a terrible choice for a primary key in something like a student database? And here's the answer, and it gets to a really core rule of databases. A primary key absolutely positively cannot have an unknown value. In database language, we call that unknown value null. Since not every student is going to have a passport, that field would be empty or null for some of them. And that immediately disqualifies it. Game over. So let's just boil it all down. A primary key is the one special field we choose to make sure every single row is unique and findable. And its number one most important rule, it can never ever be null. That's why something like a unique student ID number, which every student is guaranteed to have, is a much, much better choice. All right, so we have the structure down, we have our tables, we have our keys. But before we can actually write code to ask the database questions, we need a way to think about the question itself. We need a language of pure logic, and that's where this formal system called relational algebra comes in. Think of it as the theory behind the practice. So let's look at how we filter data on a conceptual level. The first big operation is select, and it's represented by that Greek letter sigma. This is all about picking specific rows from a table that match some condition you set. It's like going to the librarian and saying, hey, I only want books from the sci-fi section. It's how you shrink the pile down to just what you're interested in. Now, the second key operation is project, which uses the symbol pi. And while select was all about grabbing rows, project is all about grabbing columns. So after you've used select to get all your sci-fi books, you could then use project and say, okay, from just these books, only give me the title and the author. You are literally projecting only the columns of information that you care about. Okay, enough theory. That was the blueprint. Now let's pick up the actual toolbox. The language we use to build and talk to these databases in the real world is called SQL, which stands for Structured Query Language. So the very first thing you do with your toolbox is you build. Using a part of SQL called the Data Definition Language, or DDL for short, we actually lay out the structure of our database. The create table command is the perfect example. It's literally like building the physical shelves in our library. We give the shelf a name, and then we define exactly what kind of information each column will hold. And this is the moment where it all clicks. We're about to connect that abstract logic of relational algebra, the theory, directly to the practical SQL commands you would actually type to get exactly what you want from your database. The blueprint is about to meet the toolbox. So, a really basic SQL query has three main parts. First, select, which is where you list the columns you want to see. Second, from, which tells it which table to look in. And third, where, which filters for the specific rows you care about. Now, does that structure sound a little familiar to you? Let's make that first connection. Remember that theoretical select operation, sigma, the one that filters for specific rows? Well, in practice, SQL's where clause does the exact same thing. It's a direct one-to-one translation from the logic to the actual code. And now for the second connection. And, this is one that trips a lot of people up at first. Remember the theoretical project operation, P, the one that chooses specific columns? In SQL, the select clause does that job. Yeah, I know, the theory calls row filtering select, but in the practice of SQL, the keyword select is for picking columns. It's the same logic, just with a slightly confusing choice of words. And SQL can get way more powerful than just that. For example, you can ask really flexible questions using pattern matching. The % acts like a wildcard for any number of characters, and the underscore is a wildcard for just a single character. This is super useful for finding stuff when you don't know the exact spelling. So we've gone all the way from this abstract idea to a practical tool. But let's zoom out for a second. Why does any of this matter? Why has this simple model of tables, rows, and columns been so incredibly dominant for so long? And really, this is the whole point. The two are completely connected. The relational model is the elegant, logical blueprint for how to think about organizing data. And SQL is the powerful, hands-on toolbox that lets you actually build and talk to it. When you understand the logic behind the tool, you can use that tool to build pretty much anything you can imagine. I mean, think about it. From your bank account to your social media feed to your online shopping cart, it all comes down to this one fundamental model. It's just an amazing testament to the power of a simple, well-structured idea. So now that you get the basic logic, how to select rows and project columns, just think about all the huge data sets out there in the world. What kind of questions would you want to ask?